Welcome back to this NPTEL online certification course in molecular rearrangement and reactive intermediates. In the previous class, I started talking about some of the previous year questions for the carbocation and the carbanion part. And in the today's class, I want to talk about some of the previous year question covering the carbene and nitrene. Again, these questions I am discussing because this can help you to prepare for this competitive exams. So let's start with the previous year questions. So first question is I think you have all, if you have covered my lecture notes, then you must have seen this type of reactivity of carbene. So if you have a singlet carbene here, of course I think you should put 2 dot here just to show this is a carbene. So we are talking about a reaction of a singlet carbene and a olefin. So what you have learned, that if you have a singlet carbene, then the reaction is with the olefin is stereospecific, correct? So that means if you remember the structure of carbene, let me just draw one more time for you. If these are the 2 hydrogens, and then you can think about having a empty p orbital and also and then one sp2 hybrid orbital, correct? If you remember that structure of it. And then if you think about the olefin, you can think about olefin, if this is a methyl and there cis, correct? Now you can think about olefin, both sides there are single electron, they are forming bond and they are opposite spin. If these are opposite spin and there you can see the carbene, which is also singlet. Now this bond formation going to take place in a very concerted manner. So in a concerted manner, because you can see this is up, this can take the down one, and the down one it can take the up. So it can form a concerted reaction will take place. So if the concerted reaction taking place, it is going to form the product where you can see the both the methyl will be same side. So this will be the product. And if you remember, and if you do the reaction with the triplet, then you end up getting a mixture of both the product, you get a mixture of A and B, but here you will get only A. Now the next questions, from starting from this cyclopentene, you treat with A, you get to this corresponding dibrom, you got a cyclopropyl ring here, and you have a dibromide, and then you treat with silver nitrate and water, and this is end up forming B. So first thing is, if you think about the first reaction, just in the previous slide I shown you the generation of the reaction of carbene with a olefin to form a cyclopropane, correct? So it is clearly indicating that A will have some sort of a reagent which can, because this is a reaction which is going through the CBr2 carbene, correct? So if you want to generate that carbene, what will be the reagent of choice? Okay, so we have learned about the reaction called alpha elimination. If you remember, from CH-Br3, if you treat with potassium tarbutoxide, we have already discussed that these type of things in the when I was teaching you guys carbene. So please, if you forgot this, go back to that notes. We end up forming C minus Br3, then there will be alpha elimination minus Br, that is going to generate the corresponding carbene, correct? So now the reagent of choice, so the A will be CH-Br3 with potassium tarbutoxide. Now if you look into in all these option, there is 2 option, option C and option D, where you see the A is same. Now let's look into what will be your B, okay? So once you form this dibromide, what is going to happen? You treat with corresponding silver. So now if you treat with silver, what is going to happen here? And if you remember, silver will try to form bond with the bromine, and it is going to slowly cleave the carbon bromine bond, okay, and end up giving you to the you'll form some sort of a carbocation here. Now that will allow you the opening of the cyclopropane ring. So, the 5 member going to expand to a 6 member with a plus here, and you already have water in the medium. So, that can attack here to get to the corresponding product. So, you will have a bromo here and you have a OH there. So, that will be your product B. So, now if you look into this options, your option C have this product, or option D, in case option D the bromine is in the wrong place. Okay. So, that is the correct answer. Let us move to the next problem. Okay. So, in this problem, what we are going to see, that here you can see alpha keto diazo compound. If you have this alpha keto diazo compound and if you are treating with silver oxide, remember the reaction I teach you, remember the reaction which I covered again during the carbon chemistry. So, this is a reaction called Wolff rearrangement, if you remember. Okay. So, let us try to learn what is happening here. If you remember in the Wolff rearrangement, we end up formation of ketene. So, once you can think this thing as we can draw in other resonance structure, you can draw them. Correct. So, now you can think about from here in place of silver oxide in H nu, what is happening? It is converting to the corresponding okay. So, it is forming this ketene here, and now once it is forming the ketene, now you have the methanol here. So, the methanol will be attacking on the ketene, it is going to come back, and then finally this can able to take a proton. Which can take a proton from methanol to get to the final product. Okay. If you remember this reaction, so it's so this is the important step, formation of the ketene, and then the ketene the methanol can attack to that carbon, then this can able to form the corresponding ester and the negative charge here, which can take a proton from methanol. So, now the important thing is in this reaction the stereochemistry is not getting affected, because all the reaction is happening here, the ketene formation is not affecting the stereochemistry. That means, if you look into all this product which is given in the option, you have to find first what is the right product. The option A and B looks the product looks same, but only thing is the stereochemistry. So, as the stereochemistry there should not be any change going to be happened, that is why the option A will be the correct option here. Okay, again if you forgot, I will ask you to go back to the carbon chemistry lectures and go through the Wolff rearrangement. So, the next question, formation of ketone 2 from diazoketone 1 involves. So, they are saying that this is your 1, this is your 2, using PaCO2 silver and heat. Now, the question they are asking, what is the formation of ketone involves what type of generation of a carbene and 2,3 sigma-atomic rearrangement, generation of carbene and electrocyclic ring closing reactions, or it is going through generation of ketene and 2+2 cyclic addition, or generation of ketene and 3,3 sigma-atomic rearrangement. So, there are 4 these options. So, let us try to find out what is the mechanism for this conversion. Okay. Again, if you see that this is again alpha keto diazo compound, alpha keto diazo ketones. It is a diazo ketone. So, now if you have this diazo ketone, let us see what is going to happen. So, there is a 5 member and a 3 member ring here, and then there is a double bond here, there is a methyl group here, CO and N2. Okay. So, again I think if you see that the reaction condition, the role of silver is not very much clear, but one of the important role could be the activating of the corresponding carbonyl group. So, that can allow you to the generation of the ketene. So, once you use silver and heat, that can allow you generation of the corresponding ketene. So, let us first draw that. So, you will be generating a ketene here. Okay. So, now once you have generated the ketene, now what is the next thing going to happen? Now, if you see here in this particular compound, you can if you think about from here, this is 1, 2, 3, as well as here also this is 1, 2, 3. So, now you can think about a 3,3 sigma-tropic shift where this can attack here, this bond can come back here, this cyclopropane ring can break. Okay. If that is happening, that can take you all the way So, now what is happening here? Your ring expansion is happening. So, you initially, and there is a double bond going to form here, and then there will be a carbonyl group. Of course, there is a methyl here which was there from the beginning, and then there is a double bond here. So, you can see this one, between this 1 and 1, these two bond, there is a formation of a double bond. So, now if you kind of give them the name, so that suppose this is the terminal position, correct? Here you are forming the double bond. So, here this was the originally, this is the position which is the 3, this is the position of 2, that is the position of 1, and then on the other side also this is the 3, this is the 2, and this is the 1. Okay. So, what happened is actually expanded to form this 7-member 7-member ring here. So, from this the cyclopropane, and then from this ketene, the cyclopropane rupture happen of the cyclopropane, this carbon-carbon bond which allow the ring expansion through a 3,3 sigma-tropic rearrangement. Okay. So, now if you try to see the options, then we are clearly seeing that it's a generation of ketene is the important things, and then the 3,3 sigma-tropic rearrangement is the another important thing. This is not going via 2+2 cyclic addition. Okay. So, the answer D is the correct answer. Again, the product of the following reaction gives 6 line in 13 CNMR spectrum with peaks at 175 ppm, 52 ppm, 50, 46, 37, 33. So, you can see clearly from the structure of the compound is, okay, again you can see this is Very similarly, the diazoketone compounds, and once you have a diazoketone and under H nu, just now we have seen. So, these are the, I think the Wolff rearrangement comes several times in different exams. So, I try to cover some of these problems also here. So, you can see in this question also, this is a question about the Wolff rearrangement. And again, what is going to happen once you use H nu under the methanol condition, this the diazoketone is going to convert to, so there will be a, so first if you going to write them like this, you can also think about writing like this at the beginning, like as O minus, and okay, so they can they will participate under H nu to formation of corresponding ketene, so that can allow you to form the corresponding ketene here. Okay. Now once it is going to form the corresponding, so you can see these are the H here, and then there will be a methanol here which is going to attack, and then it is going to come back, minus, and COMe, which can take a proton from the methanol to get to the corresponding product. Okay. So, what is going to happen here? You end up a ring contraction going to happen through the formation of the corresponding ketene. Okay. And then from there, once you have a ketene, then you have a nucleophile methanol in the reaction, and which is going to form the corresponding ester. So, now if you try to see the corresponding carbon NMR, what we can see, there is a 175 peaks which are indicate this is a ester or amide or something which is not, of course, not a ketone. So, you can see this in this compound the ester can come at that 175, and now if you count how many different type of carbons are there, we can see there are 5 peaks for the different carbons, and you can see there is one, there will be so there will be 1, there will be 2, and there will be 3, 4, and 5. Okay. So, there will be 5 different type of carbon peaks we can able to see, because you can see in these cases you have a peak from the ester, that is 1, then you have this terminal which will be 2, and then you have this particular carbon which will be 3, but these are the carbon which are symmetric, because you can see these 2 or these 2. So, if you count total, it will be 5. So, the answer C is the correct answer. Again, now we have learned this type of reactions here. Okay, if you have this the reagent which can generate the corresponding carbene, and if you treat with the pyrols or indoles, okay, what we have learned here, because they are electron rich, you can consider this part as a some sort of enamine, correct. So, that means those this double bond can get electron density in indole. So, now if you treat with CaCl3 and aqueous NaOH, so this can generate the corresponding CCl2 carbene, and that CCl2 carbene will from cyclopropane with this electron rich double bond. So, that can end up forming with 2 methyl group here, and you have a base in the medium that can allow you so it can happen like this, where or it can happen the Cl minus can come back and take the proton. So either way, either from this or from this, from the top one, you can expect so this will open the cyclopropane ring, and also it is going to expand. So you can think about formation of this bond. At the same time, you can able to eliminate this chlorine, or you can do in the 2 steps. If you do in a single step, then this can take you all the way, keeping the chlorine here, and you will have a methyl here and here. It will take you all the way to the quinoline. So starting from indoles, it will take you all the way to quinoline, where you will have a chlorine in this position, and you will have a methyl in the C2 and C4 position. So now look into the different type of option given here. If you see among all the options, the first, of course, in these cases, the first thing is what will be the, I think it might be that if they have given 2 different answer here, means they are asking that what will the what type of carbene going to form and what will be the product. Now, now you can see the answers, answer C and answer D. So both have very same product, what the last product are same, but in the C and D one thing was different. What is the difference? We in one case it is saying CHCl is the carbene, another case is CCl2. So you clearly understand CCl2 will be the corresponding carbene, then only you can able to get to this corresponding product. So option D will be the correct option. So moving further, another very important reaction, and also it comes the Simon-Smith reaction comes several times in the exam. Diiodomethanes and zinc copper couple. Okay, so if you use that, if you remember that, this is going to form corresponding cyclopropane through the formation of the corresponding zinc carbenoid. Again, this is we discussed several problems, the mechanism, everything was you can going to find in the carbene chapter. I am going to tell you one more time what is going to happen. So first thing is, if you look into this olefin, it says Z olefin, correct? And if you remember it, the reaction using the zinc carbenoid, these are going to generate a singlet carbene. So this is going to be stereospecific with the olefin. So that means the cyclopropane which is going to form here. So first, if you remember, let me just brush you, try to tell you again, what is happening here. Once you use this zinc copper, it is going to form this CH2I and zinc going to insert. So this is called the corresponding carbenoid. Okay. So this corresponding carbenoid can react with a olefin. Can try to write some sort of mechanism where the I is getting out and this is getting in. So this is a concerted reaction again. So that's why it is stereospecific. And now if you look into that, the stereospecific product, that means both of this group, the CH2OH and the methyl will be same site. So if you look into the different option, and then what you have given, let's see the next part. After them, they given the ruthenium trichloride with sodium periodate. If you remember, this is a very good oxidizing agent which can convert the alcohol to all the way to the corresponding acid. So now we have to look into not alcohol, we are looking into the corresponding acid. Now if you go to the different option, in the option C and D has the acid, but here in case of option D, the acid and the methyl is in the same site. So this will be the correct option. Okay. The next problem again, it is you can see it says cyclopentanone, and you have this pyrrolidine, and you treat with PTSA, C6H6 and heat. So, if you treat them, what is going to happen here first? It is going to form, and then you are treating with CaCl3 NaOH. Again, if you see chloroform NaOH, then you always think about generation of CCl2 carbene, okay, and then it's treating with H3O plus. So, let us try to figure out what is happening here. We know if you have a secondary amine, a carbonyl compound, in presence of acid, what is going to happen? Minus water, so it is going to form a corresponding iminium. Now you can also in equilibrium and try to form a enamine. So, now once it is forming the corresponding enamine, if you have seen in case of indoles, so now once you have this CCl2 carbene that can form the corresponding cyclopropane. Okay. And now once you have the cyclopropane, what you are going to see there, that there will be some sort of a ring rupturing, correct? Because if you look into all the different type of products here, what we are seeing here, some of the product you have cyclopentane ring, and in one cases you have a cyclohexane ring. So, once you have formed this bond, we remember that in case of indoles the nitrogen came into the picture, correct. Here also you will going to see that this nitrogen lone pair going to give electron density here, that is going to expand this ring, going to get rid of the chlorine. So, let us try to draw what we are trying to get here. So, we now the ring got expanded, correct. And also what is happening here, you are forming a double bond here, and in the next carbon you are forming a iminium back, and then you have a chlorine here. So, if you give H3O plus to this can allow the hydrolysis, the water can attack here, and this will allow hydrolysis of the corresponding and then after the attacking there will be OH, and there will be the nitrogen going to get protonated, going to get out and going to form the corresponding carbonyl compound. So, again you can see only one option out of this has ring expansion, the option D is going to be the correct option here. So, this is another important question. You will see in the several year, this type of this type of question comes when they ask you to use two different reagents. One cases you can form, both cases you are going to form cyclopropane, but they have different reactivity. Okay. So, let us start find out what is happening here. So, in one cases we are seeing that if you use a reagent A, you are forming cyclopropane. So, if I give them a number 1 and number 2 ring, then in place of the reagent A, the cyclopropane formation happening in the allylic alcohol. So, this is allylic alcohol getting cyclopropenated. Not only that, it is the cyclopropane formation happening on the same side of the OH. And if you go to the B, now the cyclopropane is formation happening in the ring number 1, and here the double bond forming corresponding cyclopropane, and that is also happening on the other side of the methyl. If the methyl is up, cyclopropane happening from the bottom side. So, if you remember one thing, I think I taught you that if you have this type of allylic alcohol, I think this was also taught for when I think in case of the MCPB epoxidation, same for the Simon Smith the cyclopropanation. Every case is what you find out that if you have a OH group which acts as a directing group, then if you use zinc, copper and CH2I2, you will end up forming a cyclopropane on the same side of the OH. And I clearly explain you that oxygen is going to form a chelate with the zinc, because once the cyclopropane formation happening, if you remember, once the if you have a double bond here, and if this is forming the corresponding cyclopropane, then we always write this is goes via tangent state where you have a CH2 here, and then there is a iodine here, and then there is a corresponding zinc iodide, remember. So, we talk about that, the Simon-Smith reaction always goes via this butterfly like tangent state. So, the reaction happening in a concerted manner. So, here also you can see that once you have this alcohol that can coordinate with the zinc. So, you can see if you have a alcohol somewhere in your starting material, this can coordinate and direct the cyclopropanase in the same phase. You can see a picture is given here, the corresponding the tangent state for this reaction. You can see once you try to draw them in the half chair, you have this double bond here, and you have this OH here which is coordinating with the zinc. This is allowing the cyclopropanation happening from the same phase. So that means we can understand this product. If you want to form, then you have to use the Simon-Smith reagent. So that means if you go to option number A and option number B, then either option A or option B is correct, because both cases we can find this is the reagent which is given. Now go to the reagent B. What is going to be the reagent B here? So now we are talking about a cyclopropane formation happening, which is alpha beta unsaturated carbonyl compound. So if you remember, we talk about a sulfur halide chemistry, and there also I talk about that if you have a sulfur halide from either it could be a sulfonium or it could be a sulfoxonium. If you remember, I talk about both of these. And if you have this type of halide, and if you if you have this sulfonium, and then once you treat with sodium hydride or a base or butyl lithium, you can able to generate the corresponding halide, correct. And also I cover, so I covered this in the sulfur chemistry when I covered the organosulfur chemistry, and also I talk about that. And if you treat with them to a corresponding cyclohexenone or alpha beta unsaturated carbonyl compound, these are always going to take part in the attacking here. Again, there are two different things I taught you, that one, it can attack here or it can attack to the carbonyl compound. If it attacks to the carbonyl compound, it is going to form the epoxide. If it is going to attack here, it is going to form the, and then you can see the chances of attacking for these type of reagents, there are more tendency to attack to the the 1,2 versus the 1,4. But if you see in these particular cases where they want us to get to this product, then you have only this option that you have to use this as a reagent, okay, to get to the corresponding product. And you have two other options. You can so let me just tell you again. So first cases we understand. So we understand the first part, I think, right. Let me just clarify this again one more time. So we have understood that you have to use the corresponding zinc copper here to get to this product, correct. We got the A right. Now if you want to come back and understand what is the reagent of what we need here to get to this compound, you can see there is a alpha beta unsaturated carbonyl compound here. So if you want alpha beta unsaturated carbonyl compound to cyclopropane, there is a reagent which I cover in the sulfur chemistry, that is either you can use this, there is two different reagents. In the one could be a sulfonium salt, or it could be a sulfoxonium. And also I mentioned that in these two reagents, if you give a base, then what you are going to form? You are going to end up forming the corresponding halide. And I clearly mention you guys that there is a difference of the reactivity between these, because this halide is a stabilized halide in case of sulfoxonium. So, in case of sulfoxonium for this one, this is a stabilized one, here there is no stabilizing group. So, that is why this CH2 minus is more hard compared to here. So, this can go for a 1-2 addition. That means, if you take a alpha beta unsaturated carbon, so let us give this is your 1 and or this is a 1 dash, this is a 2 dash. Now, if you take this 1 dash reagent and take with a alpha beta unsaturated carbonyl compound, what is going to happen? The corresponding sulfonium halide going to attack to the corresponding carbonyl compound. From O minus, it is going to come back. You can go through the notes in details, going to form the corresponding epoxide. But as soon as you use the stabilized one, the sulfoxonium, this is going to go for a 1,4 addition, and once there is a 1,4 addition, O minus CH2 SO Me plus is going to come back and going to form the corresponding cyclopropane. Okay. And then again you can see the attacking is happening from the bottom side to avoid the steric with the methyl group. Let us move to the okay. So then the answer is going to be the B. Here you can see we have to use a stabilized halide, not a unstabilized one. Again in this question what you are seeing that what will be the product here? Again you are using a Simon-Smith reagent, but this is a allylic compound. So, now if you try to draw this type of allylic compound, you have to understand that suppose you have this double bond here. Okay, let me so what we are trying to draw here, we are trying to draw a olefin, and we have to understand there in case of to avoid allylic strain, you always want the hydrogen to be eclipsing the olefin, not the bigger group. So, you want to put the hydrogen here, so that can eclipse with the olefin, and you want to put the larger group here up. That means you want to put the silicon here, silicon is already in the up here. So, you can show the stereochemistry and you have a methyl here. Okay. So, here now you can see here if silicon is here up, and then now you have H is here. Now, if you want to see the Simon-Smith reaction in the reagent to approach, it can approach the top phase or the bottom phase, but in the top phase it can have a steric class with this SiMe2pH. That is why the reaction going to happen through the bottom phase. So, now you know that it is going to form the corresponding cyclopropane, correct. So, it is going to form the cyclopropane from the other phase. Now, if you see the example given here, they are also showing the, so these are the two cases it is showing it is going to coming from the bottom phase, but here it is showing this will be trans. That is not the correct thing. You already started with a Z olefin. So, your product will be again both of this group will be in the same side. So, the option A will be the correct option here. In this reaction, what is going to happen if you take this phenyl azide and the cyclohexanone with trifluoroacetic acid, you end up forming this product. So, they are given the product. Now, the appropriate intermediate involved in this reaction is, what will be the intermediate, from there you can get to the product. Okay. You can think about the Smith reaction, which I which I cover. I think when I was talking about the nitrene part, I covered this. So, now what is going to happen here? Again you have when I was covering I think similar type of reaction was covered when I was giving the lecture on that nitrene part, and if you remember I was using some Lewis acid like titanium tetrachloride. But once you have a trifluoroacetic acid that can protonate this. Now, if you try to write the azide like this, if you try to write them like, instead of forming this bond here, if I can write them like plus and minus, correct. Then this can attack here to the carbonyl. If you want a ring expansion, you have to attack here. So, this will be OH and N triple bond N plus and pH. This can allow the oxygen lone pair, can allow it to come back here and ring expansion, get rid of N2. This can allow you to formation of this 7-member ring where you have a NPH here. So, now if you want to go through this, what will be your corresponding intermediate? Now, if you search from A, B, C and D, you can see clearly D is the one intermediate. From there the reaction is going to the product. So, this is another question here. You are using this azide source with this carboxylic acid, and you are using a tarbutanol, and you are getting the product B. So, let us try to draw what is this, what is happening here. So, of course, there is no change in the cyclopropane. So, the change what is happening is in the, you have this COOH. Now, you have this other compound. So, you have this PO, a phosphoryl azide, again very similar reactivity we are going to see here. It is a minus. So, this can attack to the corresponding So, you can think about this, there is a N2 here. So, this O minus can attack in the phosphorus, this can come back and this will go back, and this can able to cleave this bond. Okay, so, I am not writing the entire things, I am just so here what you are seeing, OH, you have O, PO, okay, and then N minus and N triple bond plus. Okay. So, you can see what is going to happen, this O is going to come back, and this become a kind of a leaving group. So, this can get out from here, this will generate from there, will be generating some sort of a acyl azide, and if you remember, acyl azide means this is ready for the Cartius sorry, it is a Cartius rearrangement. So, this is ready for the, so if you remember, this is going to come back from the corresponding O minus, and then it is going to come back and going to form the corresponding isocyanate, correct. It is going to form. So, let me just write down for your O minus bond N. So, this is going to come back, this can migrate here, get rid of N2, and you forming the oxygen double bond carbon, double bond nitrogen, and you will have this the corresponding cyclopropane. So, let me now draw the cyclopropane, and once you know this isocyanate is going to form, you are treating with the corresponding tarbutanol. So, that can attack to the corresponding CO, this is going to come back, and so and then it can able to form a N minus. So, that means what we are finding out, the same stereochemistry will be written here, the acid stereochemistry, it will just only going to convert to corresponding NH. So, in the product what is going to be B? B going to be a structure like this, where the cyclopropane stereochemistry will be retained, whatever the substitution was here will be not affecting here, because they are not taking part in the reaction. Only thing is, this is going to convert to NH with COO terbutyl. So, this is called a BOC. So, it is going to convert to product B, which is the NH BOC, and the starting material, and there will be another intermediate going to be the A, which is the corresponding isocyanate. So, it will form isocyanate and then it will go to form the corresponding amine. Again, I think in this part I bring so many problems from the nitrogen and carbon chemistry. Please practice more and more problems for the exam. Again, thank you so much for the coming to the class. I am going to see you in the next tutorial. Thank you.